In this tutorial, we will be discussing different properties of solutions and the different classifications of them. A solution is a transparent liquid that do not separate. That's super important because if you have something that separates, it's not considered a solution because it's not homogeneous or homogeneous. For instance, if you have sour cream and you notice that the water comes up to the top of the sour cream, that was not a solution because it's separated. Solutions do not separate. They contain small particles, ions, or molecules that cannot be filtered, but they can pass through the semipermeable membranes. So colloids is another classification. They have medium-sized particles, so these are bigger than what you would consider for solutions. They still cannot be filtered, so would be like the coffee grinds being mixed in with the coffee. The coffee grinds are filtered out, but you still have some that could possibly, some chemical that comes through that's the actual coffee that you're tasting. It can be separated by a semipermeable membrane though. Here are some examples of colloids. Fogs, clouds, hairsprays, those are all considered colloids. Cheese and butter, mayonnaise, and homogenized milk. Suspensions are things that have a bigger solute, bigger pieces of particles sitting there. Those actually end up settling out. They end up falling to the bottom. Like blood. That's why you have to rock blood back and forth before you give it to a patient, is because the blood platelets have actually settled out and you have to mix them back up together again. These can be filtered and they have to be stirred to stay in that suspension. These are considered heterogeneous, not homogeneous. These are not uniform because the bigger particles settle to the bottom. So here's a breakdown of the three. We have solutions, colloids, and suspensions. Suspensions have to be mixed up and they can be filtered through. Colloids are medium sized. They cannot be filtered, but they can be separated by semipermeable membranes. And solutions, you cannot filter or separate them through semipermeable membranes. The only way to get rid of those is by evaporation. So here's a picture of what we're talking about. Notice that on this one, the suspension is the only one going to the bottom. They're also the only one that gets stuck in the filter. The other two remain after it's being filtered. And then here, the solution particles are the only ones who can actually pass through that semipermeable membrane. So a mixture that has a solute particles that do not settle out, so we know it cannot be the suspension because those settle, but are too large to pass through a membrane, so it's not a solution, it's a colloid. In osmosis, that's where we have a semipermeable membrane here. Water can pass through easily, and what happens is the side that has the particles, the water will pass through to try to dilute that out because the goal is to even out the concentrations of both of these on either side. So it's going to pass through to try to spread out these particles and thus make it less concentrated. However, there is a limit to how much it can do, and that's what the osmotic pressure is telling us. It's going to keep flowing until it hits the point where it can't flow anymore, and that has to do with the osmotic pressure. Reverse osmosis is what you'll see a lot of times to purify water. They actually push against the osmotic pressure to, instead of making it more concentrated, it'll push it this way so we can actually purify the water. So we're going reverse of what it actually wants to go. So how does this relate to nursing? This has to do with nursing, well, for one, for red blood cells, RBCs. Isotonic solutions, when you're putting something in, when you're adding IVs to somebody, this is what's happening. So you need something that's an isotonic solution when you do that, because you want the water flowing into the cells to be the same as the water flowing out of the cells. If you have a situation in which you're actually having too low of a concentration. Hypo means low. So this is a solution that's too low of concentration. The water is trying to even out the concentration, and it will inject itself into the blood cells. As a result, the blood cell actually ends up, if you look down here, it ends up bursting. That's that picture, because there's too much water in it. The exact opposite is true for hypertonic. Hyper means too much. There's too much of a concentration out here, so the water inside the cell is trying to leave to even out that concentration. And so you end up with these little shrunken cells. Finally, we have dialysis. The solvent and small solute particles pass through an artificial membrane. The large particles are remained inside. Waste particles such as urea from the blood are removed using hemodialysis. So we create this machine that sends the blood through the membrane to get rid of the bad stuff. And that's what dialysis does. And those are your different categories of solutes and solvents.